guys! Today we're going to learn about diodes. Diodes are one of the most commonly used semiconductor devices with unidirectional conductivity. In automotive circuits, the alternating current, AC output from the generator, cannot be used directly for electrical appliances. In this case, it is necessary to convert the alternating current to direct current. The process of converting AC to DC is called rectification. Rectification is achieved by using the unidirectional conductivity of the diode. A passed car's generator rectifier circuit doesn't work. Can you detect where the fault lies? With this question in mind, let's go on a journey of knowledge. First, semiconductors and p-n junctions. Second, the diode. Firstly, semiconductors and p-n junctions, substances in nature, according to their electrical conductivity, can be classified as conductors, semiconductors, and insulators. Semiconductors are a substance with electrical conductivity between that of a conductor and an insulator. Common semiconductor materials include silicon, germanium, and selenium. However, it is generally only silicon and germanium in a single crystal structure that are used to make semiconductor devices. A chemically pure semiconductor crystal is an intrinsic semiconductor. Intrinsic semiconductors have a very small number of carriers, and their conductivity is poor. In an intrinsic semiconductor, a semiconductor doped with certain trace impurity elements is called an impurity semiconductor. The number of carriers in an impurity semiconductor is much higher than in an intrinsic semiconductor, resulting in a much improved conductivity. Impurity semiconductors are classified as N-type semiconductors and P-type semiconductors. N-type semiconductors are formed by doping intrinsic semiconductors with 5 valent elements, such as phosphorus, in which the free electrons are majority carriers and holes are minority carriers. Electrons play a major role in conducting electricity. P-type semiconductor. P-type semiconductor are formed by doping an intrinsic semiconductor with a 3-valent element, such as boron, in which the holes are majority carriers, and the free electrons are minority carriers, and the holes play a major role in conducting electricity. Please note that either N-type or P-type semiconductors are electrically neutral and do not show electrical properties to the outside world. A p-n junction is a specially charged thin layer at the junction of a p-type and n-type semiconductor region. p-n junctions have special unidirectional conductivity and are the base unit for semiconductor component manufacturing. First, formation of p-n junction. When a p-type semiconductor and an n-type semiconductor are combined, free electrons in the n region diffuse into the p region, creating a space charge region. Diffusion and drift. A pair of opposing motions eventually reach dynamic equilibrium to form a p-n junction. Second, the unidirectional conductivity of the p-n junction. p-n junction with a positive voltage, that is, the p region is connected to the positive, the n region is connected to the negative, the internal electric field is weakened, the diffusion of electrons is strengthened, and a large diffusion current is formed. p-n junction positive conduction. When the p-n junction added reverse voltage, the p-n junction becomes wider. The reverse current is smaller. The reverse resistance is larger. The p-n junction is in the cutoff state. That is, the p-n junction that has a unidirectional conductivity. Second, the diode. A p-n junction with corresponding outer leads, then encapsulated in a case, makes the simplest diode. As shown in figure A below, the lead from the p block is called the anode or positive terminal, and the lead from the n block is called the cathode or negative terminal. The text symbols for diodes are often denoted by D or VD. As shown in figure B below, it is the graphical symbol for a diode. The diagram shows the diode in the direction of the arrow, and the direction of the forward current flows through the diode. The property that varies with the change in voltage applied to the diode is called the volt-ampere characteristic of the diode. The figure shows the diode volt-ampere characteristic curve. Firstly, the positive characteristics. When the forward voltage added to the diode is less than a certain value, the forward current is almost zero, and this region is called the dead zone. It's like the darkness before the dawn. After this period, it's the leap from quantitative change to qualitative change, and the other side of the shore of success. The voltage corresponding to point A is the critical voltage at which the diode begins to conduct and is called the turn-on voltage. Generally, the turn-on voltage is 0.5 V for silicon tubes and 0.1 V for germanium tubes. When the forward voltage exceeds the turn-on voltage, the forward current increases according to an exponential curve, and the diode is in the conduction state. The positive conduction voltage drop is 0.7 V for the silicon tube and 0.3 V for the germanium tube. Second, the reverse characteristic. When a reverse voltage is applied across the diode over a large range to begin with, the diode corresponds to a very large resistance, and the reverse current is small and does not vary with the reverse voltage. For reverse breakdown characteristics, when the diode reverse voltage increases to a certain value, UBR, the reverse current increases sharply. This phenomenon is called reverse breakdown. UBR is called reverse breakdown voltage. Main parameters of diodes. First, the maximum rectification current, IVM, refers to the maximum forward average current value allowed to pass through the diode during long-term operation. Second, the maximum reverse operating voltage, URM, refers to the maximum reverse voltage URM allowed to be added when the diode does not break down, which is usually half of the reverse breakdown voltage to ensure the safe operation of the diode. Third, the maximum reverse current, IRM, refers to the maximum reverse operating voltage at room temperature. Reverse leakage current at URM is generally small, but is strongly influenced by temperature. Fourth, the application of diodes. The role of diodes in the circuit is mainly rectification, clamping, amplitude limit, and afterflow. Rectification is the process of converting alternating current, AC, to direct current, DC, using the unidirectional conductivity of a diode. In an automotive alternator, it is the use of a rectifier circuit consisting of a diode to rectify the three-phase alternating current from the generator into direct current. The figure shows a three-phase bridge rectifier circuit. clamping, that is, when the diode is conducting forward. The forward voltage drop is so small that it can be ignored, thus forcing its anode potential to be essentially the same as the cathode potential, a phenomenon known as the clamping of the diode. As shown in the figure, if point A potential UA equals 0, the diode D forward bias conduction voltage drop is very small. So, the potential of point F is also clamped at about 0V. That is, the UF is approximated to 0. The use of diode positive conduction after the voltage on both sides of the small and basically unchanged characteristics can constitute a variety of limiting circuit, so that the amplitude of the output voltage does not exceed a certain value. The figure below shows a positive-negative symmetrical limiting circuit, and its output voltage, UO, is limited to approximately plus minus 5V. In electronic circuits, the diode's current storage is often used to protect other components from overvoltage damage. The circuit shown below is a protection circuit that uses a diode to protect switch S. When the switch S is disconnected due to the sudden interruption of the current, the inductor L will generate a self-inductive electromotive force L many times higher than the supply voltage. L and U act superimposed on the switch S to shorten the life of the switch S. The axis of diode D causes L to generate a discharge current through the diode in order to release the energy and protect the switch S. Today, we talked about, first, the formation of semiconductor p-n junctions, and second, the structure of diodes, volt-ampere characteristic curve, main parameters, and application of diodes. That's all for this lesson. See you next time.